Every single day, electricians in Denmark work on electrical installations, including switchboards. They often work on live installations or in the vicinity of live installations, with a risk of electric shock and injuries caused by short circuits or arcs. Statistical data from the Danish Safety Technology Authority show that the number of accidents resulting from work on switchboards has slightly been decreasing over the last years. However, these numbers also indicate that there is a slight increase when we discuss the category of accidents where the live working regulations were not observed. The consequences are often severe due to the fact that protective gear was never used during these types of accidents. Burns on hands, arms, shoulders, neck and face. Unfortunately, the descriptions of such accidents are often identical. Melted copper particles on a pair of glasses often testify that the electrician's eyes were spared as he triggered the short circuit with the uninsulated jaws of a pair of long-nosed pliers.
They called from the office in shipping and said that the lights were out. I hurried out the door, and when I reached the switchboard, I could see that a fuse had blown. There was a little dirt on the contact in the bottom of the fuse holder, which I removed with the screwdriver. I admit it was thoughtless. There was a sizzling sound, then a large bang, and the next thing I heard was the office manager, who yelled if I could hear anything. He told me that I was black and burnt in the face, so he wanted to take me to the doctor. The doctor who saw me rushed me off to hospital right away. As he said, there was something in my eyes. With sirens and police escort, I was rushed to the hospital, and I realised that my sight was in danger. I spent a long time in the operating room, where the doctors removed copper from my corneas. The doctors never promised anything, but already the next day I was recovering and my sight is now slowly getting back to normal. I was lucky.
Efterhånden der ved at få mit normalsyn igen, heldigvis, vil jeg sige.
Accidents with safety tools without proper insulation occur over and over, the statistics show. In this next, very typical accident, the electrician did not use proper safety gear, such as gloves and glasses. Among the most common causes of accidents are also insufficient screening materials. In this case, the electrician was dismounting some temporary construction site switchboards from the main switchboard when he dropped his uninsulated spanner at the main rail. This short-circuiting accident, whereby he was seriously burned, could have been avoided had he only used safety tools and made sure the proper screening material was in place. Quite a few accidents occur during metering and troubleshooting on live switchboards. These pictures are from an accident where the electrician used a measuring instrument with a maximum capacity of 700 volts AC, but there was 900 volts AC on the site. The result was a short circuit and an arc, which caused burns on the electrician's face and hands. Pressure and a lack of common sense may have disastrous consequences. In a case where the electrician was about to install an emergency generator at a farm, he felt convinced that there was no voltage on the system. The electrician never carried out a control measurement, and it did cost him his life. The consequences are rarely that severe, but the physical consequences of an electric shock are actually quite critical. When professionals are involved in accidents, they often know what went wrong. However, sometimes they cannot react appropriately or do not understand the consequences. We have to be careful when people have burns. We do not want to miss the internal burn injuries or effects of the shock, because often the visible changes that occur after an electric shock are quite limited. There may be a tiny entry hole and a small exit hole, and if you're not paying attention, you may not discover the internal injuries, even if we cut the patient open. Often the skin seems fine, but we have to open up to large areas of the body, or on arms or legs, to relieve the pressure underneath the muscle, to make sure the blood supply continues. So the best case scenario is that you end up with scars from the cuts. The worst case scenario is that you lose parts of the skin, an entire hand or foot. But of course, we do everything possible to let the patient keep as much as possible. However, the damages we see are often severe. The muscle may simply have been boiled due to the generation of heat. The Danish Safety Technology Authority recommends consulting a doctor in case of strong electric shock. In the Danish Heavy Current Regulations, Section 6, Electrical Installations, applicable from June 1, 2001, and with binding effect from January 1, 2003, it is stated that in general it is permitted to work on live or on dead switchboards, as long as the rules of the heavy current regulations are observed. The rules also include work on installations and machines. In principle, there are 3 different methods: installations that are neither live nor charged, or installations where precautions have been made for electrical danger, or installations where the electrician is in contact with live parts, either by his tools, equipment, or parts of the body. Or finally, work can be performed around voltage areas where the electrician with his tools, equipment, or parts of his body gets into the vicinity zone. It applies to all 3 methods that precautions must be taken for electrical shock, the effects of short circuits and arcs.
Here we have chosen to work on a dead installation, and when we do that, we have to make sure that everything is disconnected, and in this case, we will use the disconnector. I turn the handle down to 0, and to make sure that no one comes along and says, "OK, this one is clear, we'll start up production," I lock the disconnector with my padlock, and as an extra safety measure, I hang up the sign so that everyone can actually see that this location is disconnected for a reason. So now, no one can accidentally switch the disconnector on. Another way to ensure that the installation stays disconnected is to remove the fuse links. Before I do that, I disconnect the supply using the disconnector. Now I prepare to open the door with my screwdriver, and before opening the door, I want to put on my safety glasses due to the fact that removal of fuse links may cause an arc. I put on my insulated fuse remover, which provides a high degree of protection and a good grip. It is important to remove the fuse link in one motion. Regardless of whether you choose this method of removing fuse links or a different method such as removing wires or bus bars, you always have to make sure that this sign is visible to avoid that someone tries to activate the installation. Now we have to make sure that the switchboard is not live. We use this instrument to check the voltage level. Before using the instrument on the switchboard, I have, of course, checked that it works. We want to make sure that the installation is dead, and I choose to use gloves and glasses to reduce the risk of touching live parts and to avoid injuries by arcs. I can see that the installation is not live. When I've done that, I take off my gloves and use my voltage indicator again to check that there is no voltage and check that there is no live external control circuits. That is not the case here. Unfortunately, a lot of electricians still use the old voltage indicator, which I have here in my pocket. It's not very appropriate to use. The reason is that it has this long metal tip instead of plastic, and the long tip increases the risk of creating a short circuit and thus an arc. So I simply avoid using this one on the switchboard and put it back in my pocket. It is not appropriate to use here.
Sometimes it may be necessary to work on live switchboards. In that case, the electrician must observe a set of safety rules, in Denmark commonly referred to as laws.
Before working on the live switchboard, we want to make sure that our protective gear is secure. The first thing I do is remove my rings and my watch. When I've done that, I want to make sure that I wear the right clothes. The right clothes could be working clothes such as mine, which are particularly suitable for high temperatures and are made of fire-resistant material. Of course, it is also important that you do not wear synthetic materials underneath, as they may burn or melt easily. I put on my helmet, and now you could select either a face visor or glasses. In this case, I have chosen glasses because I like them better. I also want to wear gloves, and first I put on my protective gloves, my rubber gloves, which protect me from electrical shock, and on top of those I put a different pair of protective gloves to avoid damage to my rubber gloves. Now, some would say that it is a lot of trouble with all this safety gear, but remember that if you work without it, it is your life that we're talking about. We also want to use an insulating mat, a stepping mat that we can stand on, and it is important that you choose a sufficiently large mat of not less than 1 square metre. It has to be skid-proof on both sides and at least 2.5 millimetres thick. Now I'm ready to work on a live installation. When replacing an RCD such as this one under voltage, we have to make sure that there is no possible contact to any of the other voltage potentials present in this switchboard. We have to cover everything and make sure that only one potential is available at a time. We want to use this type of cloth, which is an insulating type of material with a thickness no less than 0.5 millimeters, and of course, we now have to fit the material to suit the purpose. We want to secure the material onto the switchboard, and a good way to do that is to use these insulating clips. As a supplement, you can also use tape. And I have to make sure that the wire ends, which I now disconnect from the RCD, are not dangerous. They are not once I put them into this shroud that I have here. The shroud has a slight barb, which prevents the wire from slipping out. Now I want to make a cover that can catch objects that may fall down. And this first part prevents us from accessing live parts in the back, and I also have to make sure that tools and other parts do not fall down in the switchboard. But we are far from finished. We also want to insulate other parts such as here. On the switchboard side, where we want to avoid that a phase conductor or a neutral wire hits the frame of the switchboard. We want to secure against the cable area here. But there is also a risk that one of our phase conductors, which is loose here, may hit the DIN rail in the switchboard. That would result in a dangerous situation, a short circuit. So we want to cover the DIN rail also. We are now at the point where we only need to cover the area between the multiple switch unit here and the RCD. So I will just put a piece of screening material here as well. A lot of accidents happen because of the inappropriate choice of tool. We have chosen a screwdriver which is marked with 2 triangles on top of each other and 1000 volts. So this is a suitable screwdriver. A different screwdriver which is also marked with 1000 volts, and in this case a bell, would also be suitable if it wasn't damaged. We can see that there is a defect in the insulation layer, so we'll put this one away. It is not suitable. We also need a pair of long-nosed pliers to hold the wires inside the switchboard when we apply the shrouds. This one is marked with 2 triangles and 1000 volts, and is completely made of insulating material, which makes this a suitable pair of pliers. Now this pair of long-nosed pliers is also marked with 1000 volts, so why not use it? It has a long piece of uninsulated material here, and when in a switchboard it may cause a short circuit, so it does not belong here. Here is a pair of side-cutting pliers. The side-cutting pliers are also made of insulating material and are marked with 2 triangles and 1000 volts. And we can see here that the jaws are also made of insulating material, which makes it suitable for use on the switchboard. We now want to start replacing the RCD. We will start by loosening this wire. Everything is already properly covered and only 1 voltage potential is available at a time, and we have also covered other live parts and conductors to the RCD. I'll take my screwdriver and my pair of long-nosed pliers and prepare to loosen the wire. But now I see that I have a cable tie up here, and I have to cut it to be able to loosen the wires. I'll just do that. Now I can loosen the wire. I take my pair of long-nosed pliers to hold the wire so that it doesn't touch any other live parts. They have been covered. But I'll use the pair of long-nosed pliers to hold the wire. I can now pull out the wire and mount a shroud on the wire. It has a little bit of resistance due to the barb on the shroud, and by putting the wire well into the shroud, the barb has a good hold and the shroud does not easily come off. I'll move on and remove the tape, make a new cover so I can take the next wire, and every single time I have to make a new cover against the live parts. It is a slow process, but it is necessary, and always remember that this is a risk to your life, so there are no easy shortcuts. When using your measuring instrument, it is important to perform a risk assessment to be able to foresee the dangers and risks that may arise. If you measure voltage over a long period of time, or if you want to determine the existence of a short circuit, it is important that the voltage probe is properly attached. Actually, it is now possible to buy probes particularly for this purpose. Here is a probe particularly suitable for use on a bolt. As we can see here, we can tighten the voltage probe, remove the handle, mount a wire, and we can now do the measuring. As you can see, it fits tightly here. I'll remove the probe again and try to find a different type of probe. Here is one where we can see that there's only a tiny area of metal in the bottom. Everything else is of plastic. This way we can eliminate the risk of causing a short circuit. I will try to connect our measuring instrument to the switchboard. And we can see that I can put in the probes to ensure a good and safe metering.
Enormous powers are released during a short circuit in a low-voltage switchboard. The extent becomes evident in an experiment conducted here in the high-voltage lab at the Engineering College of Copenhagen. A short circuit is established in the switchboard, and the mannequin represents an electrician who is working on the switchboard.
We have voltage and we can start the experiment.
The short-circuiting current is 32 kiloamps, and the short-circuiting time is 200 milliseconds. Had it been a human being instead of a mannequin, this situation could have been life-threatening. Most accidents can only be avoided if proper precautions are taken. At least once a year, the electrician must be instructed in the rules of live working to be allowed to work on live switchboards. Your life is in your hands.